In this video, we're going to talk about recursion in the list. Okay, now let's look at the code. Let's think about all the lines of code. Okay, so if you look at line 18, the list L is initialized with empty list. So at line 18, the list looks like this. Right? It's an empty list. Okay, that's with the slash. And then in line 19, if you call add front function with 10, now the list looks like this. Now this is 10. Okay, so that'll be what the list will look like. And then one more at front will make the list look like this. So this is 20. This is 10. And then list points to this. Okay. Now, if you do one more thing, so now 30. This is 20. This is 10. Okay. If you add one more element, okay, this is the last time. Okay. So 30 would be added in the front. And then 30, 40, and then 30, and then 20, and then 10. Okay. Now we're considering the recursion. So in a sense, to actually write a recursive function, you should first figure out what the recursive structure would be. Now let's think about this. So this thing and this thing is basically the same, right? So probably this is the smallest linked list. This should be base case. Okay, so whatever it is, so this is a bigger case, and then you call recursion with a smaller list, okay? And then you stop the recursion in the base case. Does that make sense? That's what you're gonna do. And then we're figuring out some recursion structure. So between the first and second list, you see something is sharing, okay? Things will be much more apparent if you consider second and third list. So you see these are shared. And then what you see from the next, you see this is the same. Obviously for the next one, you see this is the same. So what is the mean? What does it mean? So recursion is what? In a sense, if you look at this big list, the bigger list, this is really what? The value of the first node, right? Plus the list consisting of the, the other nodes. Okay, so that's basically the idea. That's the recursion structure. Now let's think about writing a print function. So how do you print the whole list? Well, this is kind of obvious now. So when you print this, use printf, right? Printf with the %d, okay? And then what? with the recurse, right? So because this is another list, we call print function, recursive function. Okay, so now based on this observation, let's write the print function. Okay. So the prototype is what? Well, that is, well, you got to return void, and you don't return anything. Print function. Okay. As we said, well, you got to print what? This one. Right? You got to print this one. So how do you access that? Well, L arrow data will be the value of the first node. So you got to print that. And then what? For the rest of it, you recurse, right? And then what's the base case? Base case is when the list is empty. So here, when list is empty, that's the base case. Well, you do nothing. There's nothing to print. Okay, now think about recursive case. Recursive case is what? Recursive case, as I said, will print the first node value. That, or you gotta actually call print a function. Right? And then what? L arrow data. In this case, like 40. And then what? For the rest of the job, leave recursion. So the function we're gonna recurse is printf. Okay. And then how do you say the rest of the list? Well, in a sense, well, the pointer, this pointer is basically pointing to like the first node of this smaller list, right? So this will be something you need to return. What is this? This is basically what? L arrow next. So that means what? You gotta pass L arrow next. L arrow next is really a list consisting all the nodes starting from the second. Okay. That's it. Okay. Let me reiterate. So base case is what? Well, when the list is empty. And then for the recursive case, you print out the first node directly, and then the other job is basically leave that job to the recursive function. So you recurse on the smaller list. How do you say the smaller list? L arrow next. Okay, so let's compile. Okay, so it seems like it's working. Okay. Oh, did I call print function? Yeah, I didn't call print function, so I have to call print function. So let's compile again. And then, as we said, 40, 30, 20, 10 will be printed out. Okay, so likewise, we can create a length function. Right? So as before, base case is what? Well, length function is not returning void. You got to return the length in integer. Right? In the base case, what? L is null with empty list. What's the length of the empty list? 0. And then how do you compute the length of this? Well, if you know the length of the smaller list, you know that's 1 plus that, right? So this will return 3 as a length, and then you got to return 4 because we have one more. Okay. So the first case is what? Smaller list. The list starting with a second. That's it. So let's call that. So that length. And then call length function. Okay. some other. And then bingo, we got length 4. Okay, so now let's do cleanup. Okay. Okay, how do you clean up? Cleanup is basically similar, right? So how do you clean up? How do you clean up? Well, you first clean up this node, right? And then what? Do the recursion clean up for that node. Make sense? Okay. So you have to be a little bit be careful as before, because what? If you free this, right, this arrow will be broken. Right? Then you don't know how to access the next arrow. So you have to be careful about this next arrow management. Okay, this has to be really legit throughout the throughout that. So, well, how do you do that? One way is store it as a backup pointer, and then you'll be fine. Right? So here, what? Let's say what? What's the base case? Base is always empty list. If it is empty list, well, you're free. Right? There's no node to free or clean up, so that's fine. For the recursive case, what we have to do, you should have this arrow, or this nodes as a backup. Okay, so that means what? You should have that pointer value. Remember, this pointer is really containing the destination. Okay? So you should have that as a backup. Okay, so I'll say smaller list is what? Okay, so store it as a backup because I want to use it later. So what do? You now delete what? Free L directly. So free L means what? This one. What L points to, this one is just freed out. And then the what? For the rest of it, you free this list recursively. So that means what? Clean up as well. Okay. So it's really basically the same principle, but for the deletion, you got to be careful about like reading the struct, and then pointer gets messed up. So you should have somehow store the backup things, to use it safely. Okay. Okay. That's it. Okay. So you can clean up. Well, cleanup doesn't really show. Okay. But anyway, that's what it happens.